Okay. Now tell me how many 7410 is the 3 input NAND gate and 740 is a 2 input NAND gate I required. Okay, the next question. How many 7410 is to be required? 7400 is to be required. You have to purchase your IC, no? You should be asked for the component. How many 7410 and how many 7400 ICs to be required to realize? See the NOT gate, this is the NOT gate 7410. Okay, because I have a 3 input of NAND gate only I am taking. Then 3, only the 4 is connected to the clock. That 3 and 5 is a no connection. Because of that 3, 4, 5 I connected as a short, and any one of the line will be connected to the clock. Output of the NOT gate I am connected to these two slave as a clock input. Okay, that is your choice. You can take this NOT gate as 7400 or 7410. There is no restriction to take what type of NAND gate to be take, because actually there is only one input for the NOT gate. Because of one input you can take 7400 or 7410. In both the case, those two unconnection, no connection will be connected as a short, and taken output of that to be connected to the slave. Okay, now next question is how many NAND gates to be required for 7410? Do you know the pin configuration for the 7410? In one IC, how many NAND can be realized? One IC, how many NAND can be realized? Yeah, 7410, tell me first. Okay, 7400. Yeah, see, I will show you the pin configuration. Very good answer. See, 7410 is a triple 3 input NAND gate. Because of 3 input NAND gate, I can only realize only the 3 NAND. Okay, pin number 1 is input, pin number 2 is input, pin number 3 is not an input. Observe it. What is the one more pin number? Pin number 13 will be act as an input. What is the output number? The output is what? First AND gate. Pin number 1 is input, pin number 2 is input, pin number 13 is input. What is the output of this? Pin number 12. You should be remember this pin configuration. If you know this, you can connect it in this. Okay. Pin number 1 is an input, pin number 2 is an input. What is the pin number? 13 is an input, pin number 12 is your output. Yes or no? See the first NAND gate. The first NAND gate, I am taking 7410, the 3 input, pin number 1 is J input, pin number 2 is connected to Q bar, pin number 13 is connected to where? Clock. What is the output pin number? The output pin number is, the output pin number is what? 13. The 13, the 12. 12 will be connected to the output. Okay. The second one, this is 7410 is also what? 3 input. See that one. 3 is an input, 4 is an input, 5 is an input. Which one is output? The 6 is an output. Then according to that you have to write the pin diagram. Pin number 3, pin number 4, pin number 5. What is the pin number 3? Where to connect it? Pin number 3? Pin number 3? Pin number 3 is connected to clock. Okay. Pin number 4? Pin number 4 is connected to Q. Okay. Pin number 5? K input. Pin number 5 is what? K input. Any doubt? The first NAND gate is over, the second NAND gate is over. The same thing you have to do in Dell simulator. Okay, the next part. Then you should be move on to the next part. Okay, what is the first one is over, second one is over. What is the remaining now? Pin number 9, pin number 10, pin number 11 is the another NAND gate. 9, 10, 11, 8 is an output. Check, observe this one. Third NAND gate. This is your third NAND gate. Pin number 9. Pin number 9 where to connect it? Pin number 9 where to connect it? Output of the first NAND gate will be connected to the input for the third NAND gate. What is the pin number 10? Pin number 10 will be connected to where? Input slot. You have input slot is there now. Input slot and output slot in the Dell simulator while doing. Okay. Pin number 10 is connected to the preset. The preset will be act as the input port. Okay. Next pin number 11. Pin number 11 is also act as an input. Where to connect? Which 12? First IC 12 or second IC 12? Because first IC 12 is already over, correct? First IC 12 is already connected. 1, 2, 3. In one IC, I can realize only 3 NAND gate. Okay. Now, the first IC pin number 11 will be connected to the second IC. Second IC of which pin number? 12. Do you have any doubt? Clarify that one. What is this 12 and what is that 12? This is the second IC pin number 12 will be connected to the 11th one. I think there is no doubt. Okay. Pin number 8 is act as an output. Correct? Pin number 8 is act as an output. Now 1, 2, 3 is over. Any doubt? 1, 2, 3. The NAND gate realization of J input is over. K input is over. Then the realization of the preset is over. Okay. Can I move on to the down one, fourth one? Is it possible to do it in the same IC? Do you have a pin? We have a pin because one IC 7410 I can realize maximum 3 NAND gate. In one IC 7410 I can realize only 3 NAND gates. Then 1, 2, 3 is over. Then what about the fourth one? Can I possible to do the fourth one in the same IC or I can insert one more IC in the slot? Is it possible in the same IC? This one, the fourth one? Can you check it? Can you check how many NAND gate can be realized in a single IC? 7410. The first one is J, the second one is K, third one is preset is over. I have one more NAND gate inside the IC? No. I can't realize only in the single IC 3 NAND gate can be realized of 3 input. Okay. Then I have to realize for the last fourth one. What to do? Can I take one more IC for the same pin? Same IC number? See, I want to realize the second part. This is the fourth part. Okay. How to realize for this one? 7410. Can I take one more IC? Clear your doubt? 7410, one more IC. Still you have a doubt? Think. Is it required second IC or one IC is enough? Pragna? Is it required? Second IC is required? Yes. Then because the second IC, what is the pin number? See, again second IC is the first one. Pin number 1, pin number 2, pin number 13 act as input, pin number 12 is act as what? Output. Yes or no? Pin number 1, pin number 2, pin number 13. See, pin number 1 is connected to the first IC of pin number 8 is connected to this one. Then pin number 2 is act as a clear. Pin number 13 is the first IC of 6. First IC of 6 is connected to 13. Okay. Next, this clear NAND gate is also over. Now again, I have one more NAND gate for the NOT. This is for the NOT. For this NOT, I am using the same NAND gate 7410. They have to connect the clock pin. The clock in the Dell simulator will get a clock. From the clock input, I connected to this 4. See, I have a NAND gate of 3, 4, 5. Actually, these are 3 inputs. 3, 4, 5. Actually, I can connect only from the clock to pin number 3. Clock to pin number 3. What to do for 4 and 5? 4 and 5. Is it possible to do no connection for that 4 and 5? Or I can do short. short connected for the 3, 4, 5. Same input will be passing for both 3, 4, 5. Which one is correct? Can I short 3, 4, 5? Any one of the line I am connected to the clock, or 4, 5 will leave no connection. If you do no connection, 3 input NAND gate, only one input is going inside that to get the output. What to do? Instead of doing no connection, the correct way of the method is 3, 4, 5 are shorted. Then any one of the input, you can take from 3 or 4 or 5, take the wire, I'll connect it to the clock. Okay. Then output of this is 6. The pin number 6 is connected to the slave part. The pin number 6 is connected to what? The slave part of both the NAND gates. First NAND gate and second NAND gate. Is there any doubt in this part? This is clear? This part is clear? I am taking 2 NAND gate IC of 7410. In the first NAND gate IC, I am realizing J, K and preset. Okay, because only 3 is possible. Because of that, I am taking second IC of 7410. There I am realizing clear and NOT gate. Is clear? All 3 input NAND gate is over. Actually, the one is left out there because unused. I don't have any 3 input NAND gate in the diagram. Only 5 is there. The 5 is I already done with 2 IC. Any doubt? Any doubt? So carefully observe because you will face so much of problem in while doing your DELT simulator. Okay. Then how to do for second part? How can you do for this part? See how to do for this one. What is an IC number I want to take? I have to introduce in the DELT simulator for their slot or in the trainer kit. The same thing in also do in the trainer kit also. I will send a video for the trainer kit also. Then how to do it? 7400 IC you have to take it. Then pin number 1, you can see this is the 7400. How many NAND gates are there in single IC? How many NAND gates are there in single IC? 4. Then one IC is enough. How many are left out with us? Our diagram. 1, 2, 3, 4. 4 of 2 input NAND gate is left out. For that single IC is enough. 740 is enough. Yes. 7400 is left out. For this, I have to do the connection for this. This pin number 1 and 2 act as input. Pin number 3 is an output. 4 and 5 is an act as an input. 6 is an output. Then 8 is an output, 9 and 10, and 11 is an output, 12 and 13. The normal is 7 and 14 is your ground. Okay, this is an IC for 7400. Okay, then you have one more IC. See, this is the JK flip-flop IC. JK flip-flop IC 7476 is the IC number. Okay, these IC you are using in the next program. Actually, if the question is easy to ask it, realize this JK flip-flop using an IC, it is very much easy. There is no difficulty of so many NAND gates. But question is given like this, realize your JK flip-flop using NAND gate, universal gate, not an IC. Because of that, I am not use the IC. IC is available. You can also check using IC, is it working or not. But he not asking to realize by using IC, he telling to realize by using NAND gate. Because of that, I am realizing your NAND gate. But IC is available. This is a 7476 is a dual JK flip-flop. What is dual JK flip-flop? In a single IC, I have a 2 JK flip-flop. Okay, 2 JK flip-flop is nothing but 2J, 2K, then 2 clock, ground and VCC. This is available in JK flip-flop. See, pin number 1 is clock, pin number 2 and 3 is the preset and clear. I told the internally the JK flip-flop have a 2 input extra, one is preset and clear. This one indicate the first JK flip-flop. 1J and the normal VCC for the common to all VCC and the ground. Pin number 5 is VCC, pin number 13 is ground. Okay, then Q. J1J is over 1K, pin number 16 is 1K and output of that one 1Q and 1Q bar. Okay, this is for dual JK flip flop. Wherever 1 is there, that is the first JK. Then you have a second JK is also there. Second clock, second preset, second clear, second Q bar and second K. Okay, these IC you are using in the program number 8 counter. Actually you are doing in the next week that program. Okay, mod 8 counter using JK flip flop. How to realize your mod n counter? Mod n can be 5, 4, 3, 7, 6, 8. Okay, any number can be given in the exam. That is realized by using JK flip flop. There you should be know this is the pin configuration of your JK flip flop. Once again, I am not explaining for that. JK flip flop, you should be know it. Okay, now you are move on to the program. This program I have to realize for JK for the NAND gate of 7400. Pin number 1 and pin number 2 act as input. The pin number 3 is an act as an output. Then the second one R is an input. 9 is connected to the common clock. The 10 is output of the master is connected to input of the slave. Then output of the slave will be connected to the latch. This is your latch to get the output. This is Q and this is your Q bar. Q and Q bar will be connected to the output port. The output port to verify your truth table. You have to verify this truth table. Okay, this is according to that you have to check for this one. Okay, this week lab you have to do for this NAND gate realization. Is it required to do the demo of this one? Is it required? If you want, I will do with the Dell simulator. How to do the, yeah, okay, now it's not enough to do it. 10 o'clock I have a class once again. There I will do the demonstration of that because it's difficult to do it by own. Okay, I will do the demonstration of that. How can you connect it for this and how to verify these two tables. Okay, I will do the 10 o'clock class for those things for this same program. Okay, okay, now I move on to the next. Is there any doubt? Is clear your JK flip flop complete? What are the things to be remembered in the JK flip flop? One is what is the disadvantage of SR flip flop? That is the forbidden case. To overcome the forbidden case, I am going for the JK flip flop. How you can be overcome? The output of that of a JK will be connected to the input. I am connecting for the output is feedback to input of both the port, J port and K port. If you do connection like this, then J is equal to 1, K is equal to 1. That will output is what? Toggle. The toggle is what? Always output should be complemented. That is for toggling case. Next one, third point. When clock is too high, J is equal to 1, K is equal to 1. What type of problem you will get? Clock is too high, then input is J is equal to 1, K is equal to 1. What is that condition we called? The output is always toggling between 0 to 1, 0 to 1, 0 to 1. For this, I can't predict what is the output. We called as an uncertainty in the output. This is problem we called as a race around condition. To overcome the race around condition, we are using edge triggering JK flip flop with JK master slave flip flop. If you do the connection with JK master flip flop, we can avoid the race around condition. The next point, JK master slave flip flop can also realize by using a NAND gate. I require totally the 9 NAND gate. Out of this 5 NAND gates are the 3 input NAND gate and 4 are the 2 input NAND gate. Then 3 input NAND gate are the JK master, 2 input NAND gate are the slave. Okay, this is very clear. There is no doubt in these things. Okay, this is very important topic for the exam, lab and our internals. Okay, now I move on.